Seven, no is full. Don't start,
start already.
the skirt all very short. I suspect they don't have enough cloth. Auntie will tell me, hey, Miss, I buy this one. I said, yeah, it's very nice, but it's not long enough. I need 3 connect together. So short, I'm going to do bed tennis or what? I bed tennis cannot, I cannot see the ball. You know, I play badminton, right? Last time I played with it. The thing comes in front of me, I don't even know how to shoot.
Catch it and throw it.
You say, I'm not aware of the thing, I just fly over. High jump even worse. Who did high jump before? High jump until I catch the pole, you see. My friend was a gymnast, national gymnast. He's very good. You remember right? He jumped over right, then he stand on the mattress. People is boom, fell on the mattress. He stand on that upright, like statue like that. I said, oh, are you steady? Are you? No, we all run. After that, some of them run after the pole. Okay, it was no time ago now. Okay, are you awake now? Hope you are less stressed. Okay? Now we're going to start. First is called length of arc. Don't worry, 30 more minutes I'll dismiss you, okay? Now, there's something called a circle. Circle, there's something called center. Okay? Now, from the center, I'm going to the basic now. From the center to here, it's called what? Radius. If I extend to both sides, this is called the diameter. Okay? Now, this outside thing is called the circumference. Circumference is a special name for perimeter of the circle. Okay, circumference. Understand? Now, I'm going to introduce you a lot of terms here. Now, part of the circumference like that is called arc. Arc is just part of the circle. This is called the minor arc. Okay, now, usually arc we call them like that. This is called arc ACB. Okay, I cannot say AB because AB can be this way, can be that way. So this is called minor arc. How about arc ADB? It's called the major arc. So minor is less than half. Major is the other one, more than half. Understand? So minor arc is the small one. Major arc is the other side. Is that clear to everyone? Okay, next. Some more terms, Okay, minor arc, major arc. Next one. This is called a diameter. This line that touches the circumference is not a diameter because it doesn't pass through the center. This one is called a chord. This is a chord. Okay, so if I draw another one, this is also called a chord. Okay, these are just chords. Understand? Actually, the longest chord is the diameter. You agree? Okay, okay. Now, next, I'm going on to 2 special names. So I'm going to draw 2 more circles. First thing, if you order pizza, they will cut. This shaded one is called the minor sector. It's a sector, cut out and eat. This side is called the what? Major sector. Everybody okay? It's called sector. Make sure you know the name. Okay, then I'm going on to something else. Another circle over here. If I just have a chord and I shape this part, this one is called a segment. Understand? Segment. So this is the minor segment. This will be the major segment. Part of it is called a semicircle. Do you understand? Don't say what kind of segment mini segment, no such thing. Okay, it's minor segment and major segment. Okay, sector must be like that. Go to the center, cut out one piece of pizza. Understand? Segment like that. You go Pizza Hut, they don't cut like that, right? So that one is not a sector. Understand? You try that, you go there. I want to cut into segment, you see they don't know. If they don't know, means they don't study maths before. Okay? Alright, so you want to cut, it's always like that. Sector is like that. Clear? Now how come to differentiate it? Later I'll tell you why. Okay? So, first page, page 247. They tell you what is a chord, what is minor arc, major arc. Okay, explain. Then they tell you what is a minor sector, major sector, and minor segment, major segment. Are you all okay? Okay, next I'm going to introduce to you the length of arc. Okay, now length of arc in primary school will be learned. Okay, primary school will learn. So I'm going to primary school teacher say. Don't laugh at me, alright? Your primary school teacher say this. Can someone tell me what's the circumference of a circle? You want to go back to your primary school? Which is your primary school? Which is your primary school? Evergreen. Anchor Green. Okay, never mind. My primary school already closed down already, so. Now, some people will tell me pi d, some people tell me 2 pi r. They are the same, huh?
Yeah.
Why? Because d is what? 2r. Alright. Do you agree that d is 2r? Okay. So usually for us, right, we use 2 pi r instead of pi d. Do you understand? We use 2 pi r. Now, everybody look at this, huh? The whole thing is 2 pi r, right? If I want to find the length of from here to here, this is 1/4 of the circle, right? Correct? Yes or no? Okay. Do you agree I like this length to be L? Do you agree that L over 2 pi r must be 1/4? Now, actually, how to get this 1/4 is actually 90 over 1260, right? It's proportional to the angle at the center. Agree? That's why when it is half, you want this half of this semicircle length. This is 180 degrees, right? That's why it's half. It's 180 over 360. Okay, then I'm going to divide by. What if I have something like that? This one is theta. I want to find this length. So theta over what? Not theta. L over 2 pi r must be what? Theta over 360. They are proportional, right? Do you agree that the length of our proportional to the angle that is subtend to the center? Okay, now I'll repeat one more term. This angle is called the angle subtended at the center by the arc. That means you see this arc is here. Can you see that this angle is corresponding to this arc? Now, what if I want this arc? Then please show me the angle that's subtending it. This one. Do you understand? It must be the same. Understand what I'm talking about? Yes or no, class? Okay, so this is called angle subtended at the center by the arc. Okay? So, if you look at the formula that is found on page 248, arc length is x over 360 times pi r. Is it okay? Is it okay? Now, from here, this is the arc length, L. I change this L to arc length. Arc length over 2 pi r is theta over 360. Actually, I memorized that. I find it easier. Angle over angle is length over length. Correct? Then the next one is like that. Arc length is theta over 360. They bring the 2 pi r over only. That's just thing over. So it's easier for them. I think this one is the easier one to remember. Agree? Length over length is angle over angle. Agree, class? Cannot. Yes. The angle must be at the middle. The angle must be at the middle. So that means you look this is the center, right? That's why it's called subtended at the center. This one, let's say, is 30 degrees. If I want to find this arc, let's say this is 8 cm. What will I do? 30 over 360 will be arc length over 2 pi 8, right? Do you all agree? Alright. Angle, arc, and the circumference. Okay? Can or cannot? It must be angle at the center. If not, it doesn't work. Okay? Now, likewise, I'm going to write something here. Likewise, I'm not going to go through all those things first. Can you look at page 257, area of sector? Area of sector. If I cut this into 4, this will be one sector, right? How do I get the area of this? It's 1/4 times the area of the circle, alright? What's the area of the circle? Each one you tell me just pi r square. Yes. Area of the circle is pi r square, right? This one is 1/4 times pi r square, right? area of sector?
Yes.
1/4 pi r square. Okay? Now, how actually did I get the 1/4? It's also from here. This is what? 90 over 360. Alright? Okay, now then I need to ask the same logic. If I have something here, 30 degrees, how would I find the area of this sector? So area of sector over pi r square, right? Will be what? 30 degrees over 360 degrees. Okay? So area of sector will be 30 over 360 times what? Pi r square. That's how you get the one that is on page 257. Are you all okay? It all falls from there. And this angle is called what? Angle at the center subtended by the arc. Is that clear? Okay. Now, what if this one now, I want to say, I want to find the area of the major sector. Then the other side. This one we got 3, 3, 0. That means what? You must read the question carefully. We want the major or we want the minor. Is that clear? It will be very clear from the question, but you have to be careful. Is that clear to all? Okay? Alright, good. Now, so I have done 2 formulas here. I'm going to write it over, right? Okay? Arc length over 2 pi r will be equal over 360. Alright? Okay? What about area of sector? Over pi r square will also be equal over 360. I think this one is easier to remember. But if you want to bring it over, it's fine. They are the same. Is that clear to all of you? Okay? So this is the tool that we are going to concentrate on today. Everybody okay? Okay? Alright. Now we'll turn back to length of arc. So I'm going to go through all the examples. If you don't have the time today, then we'll go through all of them. Okay? Now, can we all now turn back to page 249. All of you go to page 249. What happened now? Which class is that? It cannot be 301. They are too silent. Yeah, they're very quiet, right?
The physics teacher complained they noisy.
Yeah. Wow. They're very quiet. You are not noisy. Am I right? Are you not noisy? No. Okay, so you're very quiet. You're the best. Oh, do you know? Okay. Let's take a look at this picture. Alright, let's take a look. In the figure, O is the center of a circle of radius 12 cm and angle AOB is 140 degrees. Find the length of the minor arc AXB. Okay, look up at the board. They want to find the length of the minor arc AXB. Is alright? Okay, now hold up. This is how we present. Length of AXB over 2 pi 12, right? 2 pi r will be 124 over 360. Now, if you want to put degrees, both put degrees. If no one, also never mind, because it's just a ratio. Agree? So, length of AXB will be 124 over 360 times 2 pi 12. Agree? Then you'll be able to get the answer how many cm. Is that understood? I'm not going to go through quite in the calculator. You should know how to think. Okay, next one. The perimeter of the major sector OAYB. Okay. Which is the one that they want? They want the perimeter of this. Alright? What do you mean by perimeter? Perimeter means you must add up all the length, right? Alright. Okay. This one, okay already. I'm going to clean off this one. Okay, how do you find the perimeter of the particular thing?
Find the
Okay. If I straight away perimeter, I must have 12 plus 12 first. A lot of people, after they find this out, right, they forget to add 12 to 12, then die. They never say length of major arc. They say perimeter of the sector. Do you understand what I'm talking about? It's a different story altogether. If I say of major arc. Must I take 12 plus 12? No need. But this one is this one plus. Now, if this is 1, 2, 4, how much is this? 360 minus 1, 2, 4. So how much is it? 2, 3, 6, right? So this will be 236 over 360 times 2 pi 12, right? Then you will get the answer. Now I try not to truncate all the way. Usually I give one short part answer. Then you don't have to truncate so many times. Are you all okay with this question? Now if I say length of major arc A, Y, B, then you don't have this one. Do you understand? So you must be very careful when you read the thing. Alright? Now what if I say I want the perimeter of the minor sector? Perimeter of the minor sector. So that's how the answer plus what? 12. Okay? You must read carefully. Alright? Questions are not difficult if you are not careful. Alright? Okay, next. Next one now. Example 2. Okay? Study this one, the last example and I will go through. No homework for today. At least no homework for this weekend. Because tomorrow you miss my lesson because of the chemistry test. Alright? So, but it doesn't mean that it will be forever. You know, I'm not so tired, right? Okay? Alright. I'm not so tired. I'm done first one. Okay, let's look at example 2. Something is wrong in the school. Okay, never mind. We are celebrating because tomorrow is the last day of the test. In the figure, O is the center of the circle of radius 8 meter. The points A and C lie on the circumference of the circle, and OCB is a straight line. Given the angle AOB is 45 degrees and OA is perpendicular to AB, find the perimeter of the shaded region ABC. Okay. This one is not that simple, but I'm going to explain to you, okay? You want to find the perimeter of this guy, I must know this one, right? Okay now. Then I must know this length, right?
Yes.
Then I must know this length.
Yes.
Everybody agree with what I'm talking about? Okay. First of all, I'm going to find this length first. Will that be okay? Length of arc will be 45 over 360 times 2 pi 8, right? Okay. What's the answer? 560 per 8. All of you keep it up. Okay, now next. What do you think I can do? Picasso. Can you use Picasso? Can you use Picasso?
Tangent 45.
Okay. Look at the next page. They say using Pythagoras theorem, OB is 8 squared plus 8 squared. How do they know that?
What is the radius?
Actually, it's wrong, right? You see that it's not true, right? Wait. Do you know what I'm talking about here? Look at the solution. OB squared is 8 squared plus 8 squared. Did they tell you ever that AB is 8?
No.
But how do you know that it's 8? Because this is 45, this is 45. So this is an isosceles triangle. So when this is 8, this will be 8. Now even if you don't know it's fine, right? You can use sine, cosine, tangent is also fine, you can find it one. Is that clear? Because you see, OC will be 8. Right? After you find OB, you just minus off this, you can get this one. Okay, then you can find this one. Everybody clear?
Yes.
Everybody clear? Okay. So let's use the easy one. OB squared is 8 squared plus 8 squared. Am I right? By Pythagoras theorem. So OB will be square root of 64 plus 64. 128. Okay, so perimeter will will be square root 128 plus 8 plus 6.2831, right? Agree? Okay, what's this answer? Final 360. Wrong? I got the minus 8. What am I talking about now? I from oh, yeah, well, I bet already. Okay. So this one is what? Square root of 128 minus 8 plus 8 plus 6.2831. This one we can solve, right? So I'm left with this. Okay, what's the answer? 17.6. Okay? 17.6 meters. Am I right? Now, let's say we don't know that is an isosceles triangle. How will I find this side? I use tangent, right? How will I find this side? This one. I use cosine. I use cosine, then I minus off 8. I can also get this one. So there are many ways to do this now. Is that clear to everyone? So I will stop at this example 2. Okay, and I will continue the next lesson. Will that be okay?
Yes.
And on Monday, you're just supposed to give me 12.1 and 12.2. That's all. Will that be okay?